Start the topic motion along a straight line. As I told you, the motion is confined to a straight line. Suppose if you take xy coordinate system, if the object moves to and fro along straight line, then this is said to be motion along a straight line. Means only one coordinate of the system is changing with time. Y and z coordinates are not changing. When only y coordinate changes with time, when x and z coordinates does not change with time, also called as one dimensional motion, or when only z coordinate changes with time, when x and y coordinates does not change, then that motion is also said to be one dimensional motion or motion along a straight line. Now let us see this motion along a straight line and define some physical quantities. Let me take one example to define some physical quantities: x-axis, y-axis. Here is this plus 10 meters. Let me take plus 20, plus 30 in meters. Here minus 10, minus 20, minus 30. Suppose if the object is here at t equal to 0 seconds, and in time t it moves from this point to this point in time t. That means, how to define the displacement? Displacement is equal to r2 bar minus r1 bar, but here only one coordinate is changing, where r1 bar is equal to 10 I cap and r2 bar is equal to 30 I cap, because this is r1 bar and this is r2 bar. It is along x-axis, so plus I cap I have taken. So displacement is equal to 30 I cap minus 10 I cap, that is equal to 20 I cap. Its direction is from initial position to final position, that is its magnitude is 20 I cap. This is in meters. Next, path length. Let me define length of the path followed. So how to take? It is started from here, now it is moving up to here. So this length is equal to, from here to here 10 meters, from here to here 10 meters, so 20 meters. It is a scalar quantity, no need to specify the direction, just to give the magnitude, that's all. So here is the displacement, that is s bar. And one more example let me take. This is x-axis, y-axis, plus 10, plus 20, plus 30 in meters, minus 10, minus 20, this is minus 30 also in meters. Okay, this is meters. At t equal to 0, initially the object is here. Now it come to here. That means this is initial position vector, that is r1 bar is equal to 20 I cap, and this is final position vector, r2 bar is equal to minus 10 I cap. So what is the displacement? That is final position vector minus initial position vector, that is minus 10 I cap minus 20 I cap, that is equal to minus 30 I cap, and its direction is always from initial position to final position. This is s bar. And next, path length is equal to length of the path followed. So from here to here 10 meters, here to here 10 meters, here to here 10 meters. So total 30 meters. So it has only magnitude, it gives the direction. That means the magnitude of the displacement is 30 meters. This you can write 30 into minus I cap, and its direction is along negative x axis. And let me take one more example. Plus 10 plus 20 plus 30 meters, x in meters. Next, minus 10 minus 20 minus 30. Initially the object is here, so initial position vector r1 bar is equal to 20 I cap. This is initial position vector. Now it goes to here, next it come to here. So final position vector again from here to here, so r2 bar is equal to minus 10 I cap. In this case displacement is equal to r2 bar minus r1 bar. So what I can write, minus 10 I cap minus 20 I cap, again minus 30 I cap, that is equal to 30 into minus I cap. And what about the path length? It started from 20, it goes to 30, so 10 meters, again 10, 20, 30, 40, 50. So path length is equal to path length, or we also say this as a distance, this is equal to 50 meters. And it is a scalar quantity, it does not have any direction, it has only magnitude. Now you can see the difference between path length and this displacement from these examples. So in every case displacement is always from initial position to final position, and also we can define displacement as shortest distance between initial and final positions. See here, from here to here, whatever be the displacement magnitude, same is the path length magnitude. Here also from here to here, whatever be the displacement magnitude, same is the path length magnitude. But here you can see this is initial position vector and this is final position vector, because this is initial point and position, this is final position. But what is the path followed by the object? It started from here, it goes to plus 30, next plus 20, plus 10, and next minus 10. This is the final position. That means the shortest between initial and final positions. In other terms also, in other language, let us calculate this displacement not by using position vectors. Shortest distance between initial and final positions means this is initial, this is final position. So this is the shortest distance between initial and final. So it gives the magnitude of displacement, that is 20 to 10, 10 units, 10 meters plus 10 meters, 20, and this is 30 meters. So 30 meters is the displacement. So while calculating displacement, final position vector minus initial position vector, otherwise it is the shortest distance between initial and final positions. And as far as the direction is concerned, its direction is always from initial position to final position. While taking vector form, directly you are going to get the direction. Suppose if you use one definition that I stated, right, that is displacement is shortest distance between initial and final positions. In that case you are going to get only magnitude. So as far as the direction is concerned, its direction is always from initial position to final position. And path length, okay, in every case directly length of the path followed by the object. And one more observation I had. What is that? In the first example, there is no change of direction during its motion, and in this second example also there is no change of direction during its motion from initial position to final position. In those two cases what I got, the magnitude of 20 is magnitude of displacement. Magnitude of displacement and path length are equal. Here also magnitude of displacement and path length are equal. But when it started and it changed its direction of motion at 30 meters. So when there is change in direction of motion, magnitude of displacement you got less than path length. That means one more conclusion, if there is no change of direction of motion, magnitude of displacement is always equal to path length. If there is change of direction of motion occurs at least once, 1 or 2, 3 times, whatever that may be, but at least once if occurs, no doubt displacement magnitude must be less than path length or distance. This is the observation from these 3 examples, and also we understood the definitions of displacements and path length.